We're now going to move to William Baker Jones from Babcock International, and he's going to be talking a lot about data assurance. Carpigiani touched on that earlier. He touched on how they're using Celibri to do that. But we're now going to hear from Will, who has, I think, really pushed the boundaries of what's possible when it comes to assurance. And we're going to be hearing about how he's achieving automation at scale. So really looking forward to hearing his perspective. Thanks for joining us, Will.
Yeah, good morning or good afternoon. Can you hear me still?
Yeah, all perfect.
All right, fantastic. Oh, thanks, Mo. Yeah, brilliant presentations that's happened thus far today. I'll touch on briefly what some of the previous presentations have mentioned, but as Mo just spoken about, I'll be focusing primarily on data validation or alphanumerical information around Morta. So my name is William Baker Jones. I'm currently the Deputy Head of BIM and Digital Engineering for Babcock International Group, for a division within Babcock called Major Infrastructure Projects. I hold some various other positions, such as being a company owner. I also sit on NEMA, formerly the UK BIM Alliance. I host the construction domain for Building Smart UK and Ireland, and I'm also part of the GIG, which is the Government Industry Interoperability Group, as a consultant. So briefly, who Babcock? So Babcock are one of the largest defence and aerospace companies, and one of the things that we're responsible for is fleet and their subsurface fleet, i.e. submarines. But the primary focus of this session today is to talk about some of the projects that we're undertaking for major infrastructure projects. So this is Devonport, down in Plymouth in the southwest of the UK. It's the largest naval base in Western Europe and is currently the only place in the country that can maintain the Royal Navy submarine fleet. Similar to a car, the Royal Navy submarines need to go for MOT every 10-15 years, called the deep maintenance period. But unfortunately, the country doesn't have the facilities in order to maintain these assets. So Babcock are currently going on a massive infrastructure drive, looking at around £2 to £3 billion of capital expenditure over the next 10 years to look at bringing old estates up into modern standards. And in order to do that, BIM and digital engineering is a driver for that. And with all the pressures in the world at the moment, there's a lot of pressure on the Royal Navy, etc., and also on delivery of these facilities. And so we have to look at automation in ways in how we can speed up our processes and ensure that the quality of the information we're producing is top notch. So to start with sort of the problem statement, we're an enduring program. I think there's currently 1,300 members of staff working for the organisation in various capacities. Tasks are becoming sort of increasingly time-consuming and efficient, particularly when you get to the sort of billion-pound scales of projects. And as I wrote there, traditional methods are no longer sustainable. And the sustainable methods I'll be talking about today will be around alphanumerical data validation. So the sort of current process in which we're doing IFC is at the core of what we do regarding our model exchange formats. So our current process of validating IFC files is using Celibri. Now, some of the people internally will say, if you cut me in half, you'll find Celibri there. I absolutely love Celibri. I think it is probably one of the best tool sets on the market, particularly around validation, etc. But I think for the application which we're doing, it's just not quick enough. So the process in which we manually do that, just outlined in the workflow there, is where we're downloading the IFC file from the CDE, we're opening Celibri, we're loading the IFCs up, we're loading the rule sets up, and then we're running the checks on those IFC files. But unfortunately, when you're getting into these sort of large geometrical models with a lot of data in them, the processing takes quite long. But also, if you're validating on a workstation or a laptop, your laptop or PC becomes unusable. In effect, it just locks up, so you haven't got that ability to do other activities while that validation is being done. So this was the sort of the traditional checking in which we were undertaking, which was taking about 19 minutes per model in effect. And I'll talk about a bit of the numbers in a second. So we were looking at how we can speed this process up, and one of the things I did in a sort of past organization is start to look at how we can use VDI, or virtual desktop infrastructure or virtual machines in effect. And so we started to sort of semi-automate the process within Celibri, that we could automatically download the IFC files from the CD. We could save them to a centralized repository. We can then use Python to then run what's known as an auto-run script inside of Celibri to then automate that validation and then export the results automatically into a Power BI dashboard. And we got that down to about 9 minutes per model. But one of the benefits of using VDI is you can remote desktop into a virtual machine. You can then run it. You can then sort of close it in effect, and then continue on your day-to-day task. And so that meant that people were freeing up their machines, but also the VDI stuff you can run 24/7. So what we were typically doing is triggering it at 5 o'clock on a Friday, come in on Monday morning, and all your models will be validated. Jobs are good. But we want to sort of take that one step further, because even in the auto run, you're still interfacing with Celibri, you're still opening Celibri, you're still loading Celibri, you're still checking Celibri, you're closing Celibri, and all that's time and computing power that, quite frankly, we don't have, and I'll explain that in a second. So where does Morta fit into all of this? So one of the things that we're now looking at is completely devoiding of Celibri entirely. And so there's a brilliant application called IFC Open Shell, which is a Python package, in fact, that interfaces with the data behind an IFC. So you can interrogate the data, you can manipulate the data, you can parse it, you can validate it, etc. So where Morta fits into this is we are now specifying our information requirements, be it documentation, alphanumerical, and geometrical information requirements within Morta. However, what we're now doing is being able to extrapolate that data outside of Morta into IFC Open Shell using Python. We're able to validate the information requirements against the IFCs, and then spit the results back out of those checks back into Morta, back into a Power BI dashboard. And that's taking 2 minutes per model. So what does this look like when you start sort of adding time and stuff to it? So we've currently got, on a varying number of projects, 404 IFC files with an average amount of data in those of 1.2 million lines of data inside the IFC file, which is a total of 4.8 billion lines of data. Now, traditional methods would mean it would take 128 hours manually doing that in Celibri, which 8 hours a day would be 16 days, which is just unsustainable. Our model frequency drops are around about 2 to 3 weeks. So you wouldn't even get through all the models by the time the next revision of a model would be coming in. So using the automated Celibri method or auto run, we're getting it down to a lot more reasonable thing, but still 60 hours. Majority of that is opening Celibri and closing Celibri and so on. But then using IFC Open Shell and using Morta to interface that, we're now getting it down to around about 13 hours. So we're now able to basically turn around our model validation of 404 IFC files in half a day, pretty much. And that's continuously running. So one of the things that we're now looking at is, as soon as an IFC file lands in our common data environment, it will synchronize down to a central server. It then validates against our information requirements, and it kicks out the report. So end to end, our model validation is entirely automated, and it will kick out a dashboard at the end, but it will also send an email with a result as well. Because if you don't have access to the Power BI dashboard, you've still got to consume those results. Now, Babcock are unlike most people that have presented today, we are a pointing party, so we are a client organization, so we sit uniquely. Now, we're sort of validating the information coming in because we are a client operator maintainer as well. So we're going to be using these assets, not only specifying the requirements, but we're also going to be using them from an asset management point of view. So when it comes to information requirements, we kind of know exactly what we want. So we're ensuring that the information coming into our CAFM systems and so on in our COBE data sets is exactly as per our information requirements. And the benefit of that is from applying Morta and IFC Open Shell, we're technically saving 114 hours of manual intervention that, over the span of, I don't know, 5-6 years, is a significant amount of effort and cost savings. Now, we've got a team of about 40 billion digital engineers that are in various capacities, but in effect, the whole data validation activity and function has just completely been automated. Now we're looking at other applications in which we can use. So the BIM and digital engineers that we've got on a project can spend more time looking at the information management. They can look at the documentation, information requirements, etc., and really add value in those other ways. So to sort of carry on then, so that's sort of adding the sort of the metrics and the KPIs to how we're doing this. So being a secure organization dealing with some highly sensitive assets, I'm not going to show any project related information, but this is just an example of data in one of the dashboards in which we've got, where we can basically run this every 5 minutes in effect, and this is live real-time data, and we can track that over a period of time as well. So we're able to see the sort of the health rating of our IFC files, the compliance associated to them, and go throughout the project. We can filter it by organization, and in some cases we've got the same organization straddling multiple projects in the program, so we can compare organizations against organizations, and etc, etc. So again, Power BI is Power BI. I'm not going to talk about how we use that, but again, it's just really valuable to be able to see it. So we can sort of track that over time. So just to show what this is, I'm going to do, again, the classic demonstration live. But how we do this, and as I said, we're not specifying any project data in here because of obviously security reasons. So this is all demo areas. But in effect, we have our information requirements, which is just a massive table inside of Morta. It specifies the attributes, the property sets, and the things. Similar to the presentation before, we're going to be using regular expressions in our Python script to ensure that A, data is there, but also B, compliant. So how can you check that a uniclass code is compliant, etc. We can use a regular expression inside of Python to check that data. So in effect, what we do is every time the script is ran, the API inside of Python calls Morta. It grabs all this data, it tabulates it, and puts it into a list inside of Python, and then goes through. And in this instance, I've got an IFC door selected. It'll then go and find the door inside the IFC file, and then it will check the values against the requirements. And then it's simply a parsable file. It's either compliant or not, and then it saves that results and just rinses and repeat that. And it goes through every element inside the IFC file, and then spits out the report, closes it, and does the next one. And it's just infinitely doing that over time. But what we ended up finding is that not all projects have the same requirements. So we could throw any project at the requirement, but if it's a different project, then in effect, you're going to get fails anyway. So we've got our organizational information requirements in effect, or our asset information requirements to specify what asset information we want. But when we come down to the projects, we then have our project information requirement. So what we have is a centralized hub for our asset information requirement, which is what I'm showing here. And then we have the individual project information requirements to specify what information requirement is part of that project. And so Morta, the Python script will know based on the IFC metadata which project it's part of, and then it will go and call that table in Morta's API, grab the data for, say, project A, it will check against project A's table. If it's project B, it'll check against project B table. But what we can also do is specify when that information is required based on its stage. Now, you're not going to start asking for warranty and installation dates at the start of a project. That will obviously come towards the tail end of the project. So we specify that inside of Morta using our stage required and mastering dates. That mean that as the project matures, it will sequentially start upping the requirements and then upping the validations against the IFC files. So realistically, we are on a trajectory of pretty much automating our alphanumerical information requirements and our information in IFC Open Shell. But the next point is how can we take this to the next step further? How can we start looking at risk, opportunities, costs? Again, there's been a lot of conversation around information delivery plans. Again, we're starting that journey. How can we use IFC Open Shell and even just Python in general to validate against the CD and information delivery, etc. But also things about security. Again, we're really conscious about security stuff. So how can we validate the security information requirements and things like that? So yeah, that was just a really sort of brief thing, and I'll give a quick demo. So this is this may seem a bit scary, but this is the Python script in effect. I'm happy to talk to anyone who wants to talk about this. But in effect, I'll just run this quickly, and this just shows the sort of the speed in how this code works. So it's already got the information requirements for Morta. It's skipping some files. So one of the things that we ensure is that not every IFC file in the CD needs to be validated. Some of them may be temporary work, some of them may be rebar, or some of them may be any model, etc. So we exclude certain models, and we do that inside of Morta. Once it finds an IFC file it wants to check, and then pulls the information requirements and starts validating. And you can see again these are dummy models, but it's taking 10 seconds to validate. So in effect, we're end-to-end automating our validation for our alphanumerical information. So yeah, hopefully that was useful. If there's any questions, feel free to message me. I know we're way over time, but hopefully that was useful. And I'll leave it there.
That was amazing.
It's a lot to cram in such a short time. So.
Yeah, thanks a lot. I absolutely it's a whistle-top tour of what you're doing, but I think what you're accomplishing is absolutely amazing. I think what I really like overall is we've just seen 3 different approaches, 3 very different use cases. Helen had used things like Power Automate in the background. I've seen some questions in relation to that, and some people are using that. But Will was like, I'm just gonna take some code and go absolutely ham with the automation. And it's just amazing to see what you've managed to accomplish using a combination of Morta APIs, IFC Open Shell, and I think as a client, you're really setting, like, again, like another example of a great role model within the community for what the world could look like if you were if you did these things. So thanks a lot for sharing that, Will, and looking forward to seeing you again in the panel in a bit.
Yeah, fantastic. Speak soon. Thank you all.
Awesome.
Cheers. Bye.
Thank you very much.